Like,
Okay, so this question is very interesting. We were actually planning on just looking at the solution because we were kind of, I don't know if people had enough time or motivation to solve it, but we couldn't really understand what the solution was saying, so we just solved it ourselves anyway. That's kind of the story behind this question. Um, so let k be a fixed integer, okay? There are at least k plus one citizens on the plane such that the distances in any two citizens are distinct.
this one.
An election is to be held such that every citizen votes the kth closest citizen to be president. Okay? What is the maximum number of votes a citizen can have? Okay, so one thing you got to be careful of in this question is it says at least k plus one citizens, okay? It could be more.
Yeah.
Okay. As far as this question is concerned, I think you could have infinitely many citizens.
Wait, is the answer 5k plus 5?
It's close to that, but I think to get the answer, you should try small cases as well if you haven't tried it. But we actually instantly got this last time. I don't know if you remember this. So we basically instantly got that you could get 5k people to vote for the same person.
Yeah.
Okay. And how do we get that? Well, you take one person in the middle who is going to be president, okay? And you kind of clump k people really close together over here, yeah? And because there's k of them clumped together, and if there's no one else around, then all of those k people are going to vote for the president, right? Because it's clearly the kth furthest, yeah? So then we kind of just do this 5 times, right? So you just make sure these clumps are further from each other than they are from the center, yeah? And then we have 5 clumps of k.
Yeah.
Okay.
to scale.
Oh yes, this is definitely not to scale.
Michael.
So if we were to kind of draw this a bit better, we might draw like a circle and put a guy in the middle and like a regular pentagon.
Clumps of k plus 1.
K plus 1. No, they vote for the kth closest.
Yeah, but if they're clumps of k, that means in each clump there's...
They don't count themselves.
Oh yeah, true. Good point. What?
Alright, focus, okay. Yeah, so I think yeah. If you put a regular pentagon, right? So it's like 72 degrees, yeah?
Yeah.
Right, that's how to draw stuff.
The answer has to be multiples of k, right?
What if there's a different construction?
Okay, so if there's 72 degrees in the middle, yeah? Yeah, like, is it clear that, like, each one of these people clumps is closer to the middle than they are to the other clumps? It should be clear, right? Yeah?
Yes.
Okay, so that's a construction for 5k, yeah? Okay, so I want to also prove to you that 5k is actually the best you can do.
Oh yeah, that makes sense.
Okay.
Yeah.
And let's see if you can
You just have to prove that you can... Well, that seems very doable.
Yeah.
To prove 5k, you just have to...
You can prove that you can't add any more to that, but you have to... It could be another construction.
Yeah, but that's
Okay.
not... I don't think that's that hard, because you
So
take
let's...
the point that everyone votes for, and you need... And you take another point, you draw a circle that's not going to that point, but like infinitely close. And you need to take another point that's not inside that circle. You need to prove you can't take 6 points like that, of that form. And if you can prove that, then that proves the maximum is k. Because in each clump, you can only have k people.
You just have 6 touching triangles.
Yeah. But they're touching each other, they're lying inside the...
Okay.
Yeah.
So... This is our plan of attack, okay? So the first goal is to try to get we kind of remember how we got the 72 degrees thing, okay? So 72 degrees seems to be okay, right? But 60 degrees isn't okay, right? And the reason 60 degrees is not okay is because the equilateral triangle, they're getting closer to each other than they are to the middle, right? So the first goal we have is try to get a lot of stuff in a 60-degree sector, okay? And then we show that that's going to lead to a contradiction, okay? All right, so we got one person for president, yeah? One person for president, and let's suppose that 5K plus 1 people are voting for this president, okay? Okay. So then what we do is we take the furthest person, the furthest voter, okay?
Yeah.
So the furthest voter, say, is there, right? That's the furthest voter, okay? And then we draw a circle around this voter, you know? With center the president, you know? So can you see that the furthest, every other voter is within the circle?
Yeah.
Right. Okay. And now let's consider the voter's situation, okay? Let's draw another circle which is centered at the voter that goes through the president, okay? Yeah.
Yeah.
These circles are amazing, don't you think?
Oh, so they have to be like
Better than the potatoes.
Yeah. So this circle has K voters, right?
But this was my idea. The circles that go through the center, right?
wrong.
Yeah. I mean, it's all the ideas are relevant. I mean,
It's Liam's idea, but improved.
so that's kind of what a solution is, right? You put all the ideas together to solve
I
the
feel
problem.
like if I put time into this problem, I probably could.
Yeah.
Really
But
love
we're out of time now. Yeah.
Yeah. The central idea is the circle, right? 'Cause-
Yeah. Okay.
I like potatoes. No,
Okay. So
stop stealing my
guys,
pen.
so the K the inside the red circle, there's K voters, right? Because what happens is for that guy to vote for the president that we want, right? He needs K people to be in his circle.
Yeah.
That are closer than the president, right?
Mm.
Yeah.
If there are people outside,
Outside. What do you mean?
like outside the
Yeah. So those people aren't voters. Yeah.
They don't vote for President Trump.
But outside the blue one.
Yeah. I guess the point is that what I'm trying to say is, there's. Wait, what are you saying?
like then that would you would count those people when the furthest voter is like counting the K versus person.
Oh, you mean the non-voters?
Yeah.
Oh, that's a very good suggestion. This is a very this is a good, this is a high-level question, okay? So I made the claim that there are K voters in here, okay? It's not actually true, right? Because they could be non-voters, right? So then what I'm actually trying to claim is that there's at most K voters in here, right? There has to be exactly K people in there, right?
Oh, wait.
But there's at most K voters in there, right? Does that make sense?
I think this problem. Wait.
You understand what I'm saying?
Yeah.
Yeah, so there has to be K voters in the circle, including the person, so that the K furthest person is the blue dot here. Yeah, the
Yeah.
president. Okay, so what does that mean? These circles are congruent, right? So these circles are identical. So because the circles are identical, this is like a 120 degree what do you call that? Circumference, or
Yeah.
like a 120 degree angle, you know? Okay. So, and also we've taken away at most K voters, right? So there remains here at least 4K plus 1 voters. Yeah. Yeah. Okay, and there's 4K plus 1 voters, and there's 240 degrees left, right?
Yeah.
Can you see that means K plus one of them has to be in a 60-degree ray, 60-degree sector.
Yeah.
It's a 60 degrees, so there has to be K plus one. It's a pigeonhole principle, yeah? So there has to be K plus one voters in that ray, in that sector, or like, yeah, in like this, or one of these sectors, right?
Yeah.
Okay.
What's the purpose of the blue circle again?
The blue circle. It's what gives you the angles, I guess.
Furthest K higher.
So not the purpose, the definition. You want the definition of the blue circle.
Yeah, it's the furthest K.
It's the furthest voter.
Yeah.
Yeah. So there could be like K voters in here. Yeah.
Yeah.
Okay. So now what we got is we got K plus one voters, at least K plus one voters in a 60-degree sector. Yeah. Okay. So let's deal with that situation. So what's wrong with that? Yeah.
It wouldn't be the case.
Yeah.
That's just
So we're just gonna make this argument rigorous. So there's lots of ways to do this, but I thought the final argument that Alex provided was probably the nicest because it was kind of the because it removed all the extra stuff. You know, you could literally just do lots of calculations. So maybe to give you some motivation, okay. So if you had a 60-degree thing, okay. If you had a guy that was just here, that was like one of your voters, right? Then their circle would just be big enough to like to hit here, okay? So that there's nothing outside their circle basically inside the sector. Yeah. And you can see that's a problem because there's K people in his circle, right?
Yeah.
But there's K plus one people in the sector, so that last person has to be over here somewhere, right? And if they're over here, this could already be a contradiction because you just picked that guy as the furthest guy out of the K plus one already, right?
Yeah.
Okay, so, but that's why 60 is important because necessary because if you have a smaller or bigger, if you had a bigger angle, the circle that you draw kind of ends up like over here, and they can kind of sneak in over here.
Yeah.
You know? Okay, but that's just the heuristic. What about the proof? So how did Alex do this? Let's think. So you have 60 degrees, and then you have an arc, yeah,
Yeah.
and you have some point here is the furthest guy out of the K plus one people, yeah. So the K plus one people in this 60-degree thing, yeah. Okay, and that's the furthest guy, yeah. And so this sector should contain all the K plus one people.
Yeah.
Okay. Okay, so what we're gonna prove is so we're gonna prove that this guy here, we're gonna prove he's a non-voter, which is a contradiction. Okay. So we said all K plus one people vote for the president. We're gonna actually prove the first guy doesn't actually vote for the president. Okay. All right. Like, yeah.
On the slide that you put that cell is not longer than the distance to the president.
Yeah.
Can I just say if there's K plus one voters in a circle, in the circle that passes through the center, that implies all K plus one voters are closer to each other than
Yeah, so there's a few things, right? Because some people might not be like Okay, so and I'm not saying this is the only way to do this. A lot of ways to do this, but I just like this way for some reason. Okay, so you take one of the other K people, yeah?
Yeah.
Okay. So it doesn't matter which one you take, so that means the conclusion holds for all of them, yeah? And then you draw a triangle. You draw a triangle, okay?
But you can just log the one at the center as a non-voter. Because there's one at the center of the, like,
What?
where? Because they're groups of K, right?
The one at the what do you mean at the center?
Because you take the circle you know how you took the circle centered at,
Yeah, but I'm not right now, huh?
yeah, but you can take suppose they all vote, correct? And you can take the circle of one of them.
Yeah, I think I do that in another approach. Yeah, you can show that circle covers the whole sector basically.
Yeah, and that they all must.
Yeah, that's fine. Yeah, that's another approach as well. That does work. Okay, so what do I want to show about this triangle? Okay, I want to show that this side here is the shortest. Yeah, this is what I want to show. Because if I show it's the shortest side, or at least it's shorter than this side, so it's short. This is longer, okay, and this is shorter.
It's inside this segment, like.
What do you mean?
Like the points inside that segment could be longer.
Well, so I guess your question, if it doesn't depend on the 60 degrees, then it won't be valid. Because it can be longer if it's not 60 degrees.
60 degrees.
Yeah, but see, that's the thing. Like the question didn't involve 60 degrees, right? So it can't be. It doesn't have the same impact, right? Okay, so we're trying to show that side is shorter, yeah? If we're going to show that side is shorter, then what that means is obviously the person there is closer than the president, right? And if all K people are closer than the president, then that guy is not going to vote for the president, right?
Yeah.
He's going to vote for the K closest. The president will be K plus first, closest or further, yeah? Okay. So this argument is kind of simple. So we'll let this angle be, we'll let this be alpha. This could be like beta, and this could be gamma, yeah? Okay. So we started with the assumption that that this side was shorter than the longer side, right? That's the assumption at the beginning. This is shorter because this guy is the furthest, yeah? Yeah? From the president, okay? And if that guy is shorter, right, then the angle must be smaller. So the gamma is smaller than beta, yeah? Yes? Okay, so if the gamma is smaller than beta, okay, and alpha is smaller than 60 degrees, yeah, then that means beta plus gamma is greater than or equal to 120 degrees, right? Which means that
Alpha is less than 60.
which means that so beta is less than gamma, but bigger than gamma, right? So beta must be bigger than or equal to 60 degrees, right?
Yeah.
Yes.
Yes.
Which means it's bigger than or equal to alpha.
Yeah.
Which means that
Oh,
Oh.
the length of it.
yeah, which means the lengths are bigger, yeah? So this is in fact shorter than that, yeah? Does that make sense? Yeah, I think there's lots of ways to show the conclusion. I think if you just kind of have an idea of what you're trying to do, the first step was probably the most impactful because you got K+1 voters into a 60-degree sector. You know, I was actually, when I was planning on explaining this, I was actually going to wait at the end to see if, like, you noticed any sketchiness in the proof, but Charlotte actually already pointed it out during the proof, which is quite amazing, actually. He pointed out that the furthest voter, the circle might not contain all voters. Yeah, yeah. Actually, it took Alex quite a while to realize that. Yeah, and most of us kind of just never really detected it, so it was very good find.
Voter, the circle from the furthest voter may not contain all voters. But
yeah, like the argument before was like, why was 100? Like why was it 4K+1 in a 240 degree? It was because there was K up the top in the 120 degree, and 5K+1 minus K is 4K+1, right?
yeah,
But the problem is there might not be exactly K voters up there, right? Because the person doesn't need them to be voters for them to decide who he votes for, right?
sure.
He just needs them to be citizens, yeah? But the point is, even if they were citizens, they would just take less voters away from the 5K+1 voters.
Yeah,
And you'd have more than 4K+1 voters.
Yeah.
And all you need is that there's more than 4K+1 voters to get K+1 in a 60-degree region, yeah?
yeah.
Okay. Wow, that's pretty... I think we're doing these a bit too fast.